Hello again. In this video, I'm going to be going over the exercises for loops, iteration, and for while and do while loops. Starting with this first problem, to write a program that uses a for loop to compute the sum of even numbers between 0 and 20,000, then write another two different loops that do the same thing. Let's start by making one loop first, and then we can worry about the different loops after. So, what does a loop look like? Well, let's make one. So, anytime that you are coding and you want something to happen more than once, the way that you would do it without really thinking too much is probably something like copy and pasting, right? If I wanted to say hello world 5 times, I could go, hello world, hello world, hello world, hello world. This is really messy. It's not really very elegant, not nice to look at, and it takes a long time to code. What happens if I want to do this 100 times? It's not really that ideal. So in order to write code to tell the computer to do something repeatedly, we use what's called a loop. And a loop just says any code within this loop, inside the loop, is going to run multiple times, is going to be repeated. So the for loop is the most basic form of this, which is to do something for a certain number of times. So for some number of times, I want to, for instance, write hello world. Let's say I want to do it 5 times, for example. So inside the parentheses of a for loop, there are 3 things that go in here. The first is is what happens at the initialization of this loop. As soon as you hit the loop, what's the first thing that happens? And in most cases, you're going to want to define a variable here, and you can use that variable to count through your loop. So I'll declare a variable called counter that's going to start as 0, and every time that my loop is going to go through, it's going to change. Now, when do I want things to stop? Well, I want my counter to stop once it hits 5. So as long as my counter is below 5, then I'm still going. But every time my loop is going to run, I want my counter to go up so that eventually it's going to hit 5 and stop. And so if I want my counter to go up, we're going to take our counter and increment it. You could write this in 2 different ways. You could write counter equals counter plus 1, but the most common form of syntax you're going to see for this is just counter plus plus, which literally just means take counter and increment it by how much? By 1. And now if I run this, sorry, there's an extra semicolon here. Don't need that one. Write hello world 5 times without the light space. Let's put that white space in so it looks a little bit more elegant. There we go. Hello world 5 times, just like we wanted. Okay, so now our exercise is not to print hello world 5 times. It's to compute the sum of even numbers between 0 and 20,000. So there's already a few things going on in here. Let's break this problem down before we delve into it. A for loop, we've already built a for loop, so we can tinker with it as we need to. If we're computing a sum, you always need to figure out how to compute the sum, which usually means you start at 0 and add numbers to it until you have a sum. So let's make sure that we have that sum. We're going to have an int sum, and it's going to start at 0, and we're going to increase it over time. We are adding the even numbers between 0 and 20,000. I guess it doesn't say inclusive, but we won't be too picky about that. So right now our loop is going from 0 to 5, and instead we want it to go from 0 to 20,000. That's actually not too hard. We can just say, instead of going 5 times, go 20,000 times. We don't want to print hello world though. What we want to do is add to our sum. Now, what are we adding to our sum? We're adding only the even numbers. So, in order to figure out if a number is even, what I want to do is figure out if I divide the number by 2, do I have a remainder or not? If I can take a number and divide it by 2 with no remainder, it's even. If I take a number and divide it by 2 and it has a remainder, then it's odd. So in order to figure out if division by 2 has a remainder, you can use an operator called modulo. So if I take, for instance, let's set this aside for a second. If I were to take an integer, my integer, and say 5, and say if this is an even number, then print it is even. In order to figure that out, I can say my integer modulo 2 if that is equal to 0. So my integer, the number 5, modulo 2 means calculate the remainder of dividing 5 by 2. So 5 divided by 2 is, 2.5. But we're just looking to see what is actually the remainder if you were to work it out on paper, right? If you work it out on paper, what you get is 2 divides into 5 twice with a remainder of 1. So my integer modulo 2 is going to give me 1, which is not equal to 0, so it's not even. So when I run this code, it should do, nothing. But if I were to make my integer equal to 6, this is an even number. 6 is even, which is exactly what I want. So let's take this and put that into our little loop here. We don't need my integer. I guess so we can bring it with us for now, and we'll remove it. So now, okay, a few things that we don't want to do in here is, first off, we don't want to be printing things because it's not necessary. We just want to be adding. We don't want to be using the number 6. What we want to be using is the numbers from 0 to 20,000. So here's our 0. It's going to go up every time, so eventually it's going to hit 20,000. So at some point, counter is going to be all the values from 0 to 20,000, which means I can use my counter variable instead of using my integer. So counter modulo 2 is 0. So this is going to print out it is even for every time I find an even number from 0 to 20,000. But again, I don't want to do that. What I want to do is add this to my sum. I'm going to take my sum and I'm going to increment it by the counter. Now, I could do sum equals sum plus counter. This is one way to write it. But, this is a lot of text that you don't actually have to write. You can make it a little shorter by using, again, another special operator. So you can use plus equals to say, take this and increment it by whatever's on the right side of this this expression, which is counter. So sum is going to start at 0. It's going to be incremented by the counter every time the counter is even, and only when the counter is even. Just out of curiosity, I guess we can print our result at the end. Let's figure it out. What is the answer? 99990000. I guess that's what the sum is. You can maybe check that somehow if you want to, but one way we can actually check it is by doing the rest of this question, which is write another 2 loops that do the same thing. So here's our first way to do it. Let's try another way. So we'll just copy this and try it again. Okay, so we still need our sum to start as 0. Now, notably, our counter, when we write it inside the for loop here, counter is only actually tracked within the loop. As soon as you leave the loop, counter is not known anymore. So we have to make a new counter in our second loop. Now, this time, one way we can do it is, well, think about this. We're only adding the even numbers, so rather than checking if something is even, what if we just took the numbers from 1 to 10,000 and just doubled them all, right? So instead of having, 0 plus 2 plus 4 plus 6 plus 8, which is what the first one is doing, it's looking through every number, and if it's even, adding it, otherwise not. In this one, we're taking 1, 2, 3, 4, 5, 6, and so on, and we're just taking double of each of them, which is going to end up with the same set of numbers, right? 2, 4, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and so on. So instead of using modulo, we can actually just make this even simpler and say sum plus equals counter times 2. And our sum should be the same thing. I guess we'll make it nicely spaced so you can read it. Look at that, both sums calculated the same number, so it's a good sign that we're doing things that we want to be doing. Now let's wrap this up with one more, which is that right now we've been going up. We've been starting from 0 and going up to 20 or 10,000 each time. Let's go the other way, because we can. So we're going to start with, now I think this is not including 10,000, so we're going to start with, I guess the number next, like below that. So how about instead of counting from 0 to 20,000, we count from 19,999 and go down to 0. So as long as our counter starts here, we'll keep going until our counter hits 0. And instead of incrementing our counter every time, we're going to decrease our counter every time. So essentially what we're doing here, and we'll just steal the code from our first loop. Instead of adding the numbers, 2 plus 4 plus 6 plus 8, what we're actually going to add is, 19,998 plus 19,996 going all the way down. So it's the same addition, just going backwards. But all three of these sums should be the same thing, and look at that, they are. So, brief introduction to for loops in this very first exercise. Okay, now let's look at our next one. So now we're doing while loops. Okay, write a program that initializes a large number x and a small number y, then uses a while loop to find the largest number smaller than x divisible by y. Okay, so again, this sounds like a lot already to handle, but let's just break it down, and then after that it should be a little easier. So let's we're going to comment all this out for now. I think we're going to come back to this later, but just leave all that code up there, and we're going to initialize a large number x and a small number y. So, you know, x, make that 1,000. It's a nice big number. And we'll make y something small, 3. So, use a while loop to find the largest number smaller than x that's divisible by y. Well, if we're looking for the largest number possible, that means we want to probably use a loop that's going to start from a big number and go down until we can find something that meets this condition of divisible by y. So for anything else, how about we just write that condition out? So we're looking for, you know, if something is divisible by y, meaning that if the remainder after dividing is 0, and we'll see what that number is going to be. Just as find it, so I guess we'll print it out, right? Print out. So the number is the largest number smaller than x and divisible by y. It's a long line of code, which you probably can make a little neater, but yeah, actually, I guess I can do it like this. Yeah, that should be okay. I'll space it down this way. There we go. So, x divisible by y. Okay, now, what is the number that we're going to be checking? Well, we have to use a while loop, because we have to find all the numbers that might meet this criteria. And if we're starting from here, then what makes sense is probably to use this as our counter and go down in our while loop. Now, instead of using a for loop, we're using a while loop for this. So, our condition is going to be, well, once we reach a number basically once we reach 0, we probably are out of luck, right? Or I guess technically once we reach y, because clearly y is divisible by itself. So as soon as we've been counting down, eventually we'll hit y, and y might end up being the largest number smaller than x divisible by itself. So we're going to have a loop that's going to take our counter, and our counter, we want to start at whatever the value of x is, and we're going to go down. So starting from x, as long as our counter is bigger than y, we're going to go down. And when I say go down, what I mean is literally we're going to take the counter and we're going to decrease it by 1 every time. So our loop here, ignoring the if statement for now, says start from whatever the value of counter is, check to see if it's bigger than y. If it is, then we're going to keep running this code over and over. And our counter is going to go down every time, which gives us at least some assurance that this loop will eventually reach an end. If I didn't have this line of code, this program would run forever, because counter is always going to be bigger than y, and then the whatever is inside of this loop is just going to keep going and going and going, and it's called an infinite loop, which you don't want. So to make sure that we don't have an infinite loop, we're going to use our this line of code to decrease the counter so that eventually it will be less than or equal to y, and our code will stop. In the meantime, though, I want to be checking to see if something is divisible by y, and in this case it's my counter, because my counter is going to keep going down. Okay, now, there are two ways that we can handle, there are a few ways that we can handle actually ending this loop once we find the number that we're looking for. Because right now, here's kind of an issue that we're going to run into, is that the way that the code is written right now, maybe I guess I can just run it and I can show you. We have a bit of a problem, which is that it's printing out all the numbers smaller than x divisible by y, but I only want it to print one. So there's one kind of hacky way to do it, I guess. It's not the ideal way, which is to use the word break. So if I write break in here, this is an instruction to C++ to say go into whatever loop you're inside right now and leave it. So by writing break here, as soon as I find the first largest number that's divisible by y, that's smaller than x, it immediately leaves the loop and we're all done. So this is one way to do it, but probably not the most ideal way. Sometimes break can do very unpredictable things, especially if you're not keeping track of where you are in your code. So this is one option. Another option is to modify our condition to say, well, if once we've actually reached a point where the counter is divisible by y, then we want to leave our loop, right? Right now, I have an if statement to output this message as soon as I find what I'm looking for, but I don't actually have to do that in the loop, right? As soon as I've figured out the value that is divisible by y, and I know I will hit one because x is big and y is small, so eventually I'll reach a point where it is divisible. Instead of using this condition, I can actually just change the condition completely. So instead of while counter is bigger than y, I can actually just say while it's not divisible. And then I don't need to have this. In fact, my code in here can actually just be basically nothing. It's just decrementing the value of counter. And eventually, counter will reach a point where it says, you know what, okay, now this is divisible by y, and that's the biggest number I could get. Now I can print out my message that I want to print. So outside of the loop, I can print what the value of counter is. And this should do the exact same thing. Okay, this is, let's see here. While counter, let's see what mistake I made here. Counter is x. Yes. Maybe you can spot it. I just noticed it now myself. Give yourself a second to see what I did wrong. You see it? So my condition is to loop as long as it is divisible by y. But that's the opposite of what I want, right? I want it to loop while it's not divisible by y. So to change that, I want this to be my condition. And that should give me what I'm looking for. Yeah, 999, the largest number, smaller than 1,000, divisible by 3. Let's just try a weirder number to see if I can make sure this is working correctly and I didn't just happen to run things one time. 988 is the largest number, smaller than 1,000, divisible by 13. I guess that probably makes sense. You can maybe do the math and double check that, but it sounds right to me. So, several ways to approach the same problem. Break is something that you might be very tempted to use because sometimes it does solve the problem really quickly, but I think in particular that this is actually, like if you don't have what's here, I think this is actually a bit more elegant than the solution that used break. So I would recommend something more like this to solve this kind of problem. But I believe that's everything for that problem, so now we can move on to the next one. All right. For loops are while loops, which is technically true, I suppose. For loops are, or I guess while loops are a more general form of for loops in that you can replicate any for loop that you want with a while loop. So go back to your first program that used for loops, that's the counting to 20,000 one, and create a while loop that does the same thing. Well, this actually shouldn't be too hard for us. So I'm going to comment all this stuff out again. Okay, so I want to do this, but I want to use a while loop instead of a for loop. So, well, what's the condition that I'm looking for? I can't have all this stuff in here, but I do want to have all of the components of this happening inside my loop. So what I'll do is the first part of this I want to take out because I want to have this happen right away before my loop starts. So I'll put it right before the loop. The condition that I want is for counter to be less than 20,000, because once it is, I want to stop. And then so I can delete this. And then counter plus plus is what I want to have happen at the end of every time my loop runs. So I can actually just take that and put it down here. And I'll run it, and it does... Oh, what did I make a mistake of? I'm missing a symbol somewhere. Counter plus plus should have a semicolon right there. Okay. And there we go. There's our answer from before. 4 nines, 4 zeros. And look at that. That didn't take long at all. And so you can fairly easily convert any for loop you want to into a while loop. Doing the reverse is not only sometimes very difficult, but also sometimes impossible. And I think in our next exercise, we'll see exactly why you may have no choice but to use a while loop or do while loop. Okay, final exercise. Write a program that sums positive numbers entered by the user and prints the total once they enter a non-positive number. Okay, so let's get that going. Okay, so we'll get rid of all this. So first off, we need to get stuff from the user. That's pretty important. A few general rules again, as always. Anytime you're getting anything from the user, so we're going to get their input. Before you ask them for anything, you should ask them what you want. So please enter a positive integer or non-positive to quit. And then we get their input. Okay, now we want to do this repeatedly. So what we're going to do is we're going to use a do while loop. We're going to say do this whole thing repeatedly. All the code that we're about to write, and stop once their input is not positive anymore. In other words, is less than 1. So if we just stop right here, we actually can verify that this is doing what we want to just by running this and making sure that our code is going to loop and that it leaves when we don't want it to loop anymore. So if I run this, enter a positive integer, non-positive to quit. So positive, and it quit. That's not too good. What is going on here? So, let's see, do this while the input is less than 1. Very interesting. Well, let's check and see exactly what happened to our input. So, anytime that you're not sure about what code is doing, it's always a good idea to use some approaches like printing, for instance, to try to see, okay, why is my code not doing what I expect it to? Because I wanted it to loop, and it's not. So why is that the case? Well, let's see. Your input is input. Because clearly something weird is happening here. So let's have them enter something, get the input, and then echo it back so that we can see what apparently might be happening here. 6. Well, my input is 6. Okay. Once again, I have the reverse condition that I was looking for. So I've kind of pieced together in my head, okay, why is my code not doing what I expected? It's because once again, I'm kind of thinking backwards here. I want my loop to go while the input is positive, not while the input is non-positive. So in order to make sure I'm going while it's positive, I want to not have less than 1, I want to have greater than 0. So, just a little brain meltdown for me, but if this kind of thing happens to you, and it will probably happen to you, it's very quick to try to... One of the quick ways you might want to figure something out is actually doing something like printing out a value that you can't see, just to verify in your head that, oh, okay, this number is what I think it is. And then when you step through each line of the code in your head, you can sort of see, okay, this line's doing what I think it is, this line's doing what I think it is. Oh yeah, okay, this is the line that has the mistake. So, okay, we don't need this anymore. Now let's make sure our code is correct. So while we're entering positive numbers, this is going to keep going. Positive, positive, positive. And when I enter a non-positive number, like -7, then it stops. Okay, great. Now, it's supposed to sum these numbers, so we're going to do that and print the total once they enter a non-positive number. So let's get our sum. Now, initially our input we're going to start out with 0, and then we're going to hope that they type in something bigger. Because the first thing that we want to do every time they entered a new number is increment our sum. So I've changed the initial value of our input to be 0, just so the first line of code inside of our loop is to take our sum and increment it by the input. So the first time that our code runs, this does nothing really. But every time after, they've entered a positive integer, and so once they enter a non-positive one, it'll quit and it won't add that non-positive integer. For an example of what I mean, let's suppose we do this wrong. Let's suppose I take this and put this in the wrong spot, which in this case would be down here. And let's see what happens. So to verify what our sum is at the end, we're going to want to print it out. Our sum is sum. In fact, you know what, we'll actually add an extra space in here just to space it a little bit. So far I've been using endel all the time to indicate I want to put a line space down, but another way you can do it is actually with /n, which is just a special symbol that means push things down a line. You'll notice that this appears in blue as opposed to our text, which appears in green, and that just means that this isn't going to literally print /n, it's going to print a space. So let's run this just to see. So if I enter, 8 plus 6 plus 6 should give me 20, right? Now if I enter 0, our sum is 20. Hooray, that's what we want. Now, but here's the thing. Just because I did that doesn't necessarily mean my code is correct. Allow me to run this code again, and I'll show you why there is an error. Okay, suppose I enter 8, 6, 6, and this time instead of entering 0, I enter -5. Sum is 15. That's not quite right. Why is that happening? Well, when you look at the order in which things are happening inside of the loop, we get the number from, we ask the user for a number, we get that number and store it in our variable, and then we append that, or we add that to our sum. The thing is, when we enter a non-positive number, we want to quit. We don't actually want to add that to our sum necessarily. So right now we have this issue of, because of the order in which our code is set up, it's always going to grab that non-positive number, modify our sum, and then decide, oh, okay, now is it time to leave our loop or not? So notably, the condition inside of this while parentheses here is only actually checked once you hit the line, not when the condition actually is changed. So even though over here we put a non-positive number into our input, it isn't until we actually reach line 62 down here that we actually say, oh, okay, now it's time to leave the loop. So if we want to fix this, this is why we might need to take this line of code and put it back up here. And now when I enter the same numbers, 8, 6, 6, -5, I get the 20 that I desire. So in general, anytime that you are that you want to make a loop that you know is always going to run at least one time, do while ends up being often the easiest way to do it, because it's specifically intended for you to do everything once while something is true. So if something is, in this case, a positive number, and you want to do it over and over again, you can. But if you don't want to do things more than once, the condition will be false and you just won't have it happen. For a while loop, without the do part, that's something that you might want to use if there's a possibility your loop will never run. There might be a condition where you have to start with some positive numbers, and if off the bat you already have a negative number, then you might never want your loop to run, in which case you want to use just while and not do while. But in general, just like most things in coding, experience is one of the best teachers, so hopefully with some more practice you'll get very comfortable with using loops and things will be easier for you. So I'll see you in the next video. Take care.